Today we are revisiting lesson we looked at the very beginning of this unit, where all we did was write the systems of equations. Today we're actually going to take those same problems, write the equations again, but now we're actually going to solve them now that we've learned all the methods to solve. So number one here, Melting sells half-gallon containers of frozen yogurt for $4 each and 1 gallon containers for $7 each. So we're going to define a variable for half-gallon containers and one for 1 gallon containers. So I'm just going to say X is half gallons and Y is 1 gallons. So it says one day Mel sells a total of 50 containers of yogurt for a total of $287. Well, first equation, just based off the 50 total containers, we could add X plus Y equals 50. So there's our total containers. And the second one is what I like to call your money equation. All the money numbers go together. So half gallons are 4 each, so 4x. 1 gallons are 7 each, so plus 7y equals $287. So there's our system. This one sets up well for elimination. They're both in standard form. Okay, so if I were to line these up, so x plus y equals 50, 4x plus 7y equals 287. Now we can choose how we want to cancel out a variable here. I'm going to cancel out the x's. If this is 4x, I need this to be negative 4x. So I'm going to multiply that equation by negative 4. So that becomes negative 4x minus 4y equals negative 4 times 50 is negative 200. So now we got x's that cancel. 7y negative 4y add to be 3y. 287 and negative 200 add to be 87. And so then we're going to divide 87 by 3, and you get 29. So y is 1 gallon containers, so we know that is 29. So if we plug that back in, I'm going to use this equation, x plus 29 equals 50. We'd subtract 29, and we would get 21. So we get 21 half-gallon containers and 29 1-gallon containers. Okay, skipping down to, actually number 2 we were going to skip. I don't like that problem, so we're going to move on to the third one. One says, during 1 week of playing basketball, Manu Ginobili hit 30 shots to the floor and scored 68 points. Each shot was a 2-pointer or a 3-point shot. So there's our two variables. Let's say X is 2-pointer shots, so 2 pointers. Let's say Y is 3-pointers. So we know he hit 30 shots. So X plus Y equals 30. And we know he scored 68 points. So it's like the money equation, so it's points now. So 2 points for a 2-pointer, so 2x, plus 3 points for a 3-pointer equals 68 points. Okay, just like the last one, I'm going to line them up. Sets up well for elimination. And I'm going to choose to eliminate x again. So if this is 2x, we need this top one to be negative 2x. So I'm going to multiply that equation by negative 2. So that gives me negative 2x minus 2y equals negative 60. Now we got x's that cancel. 3y plus negative 2y just gives you 1y. 68 plus negative 60 gives us 8. So there we got y equals 8. So he made 8 3-pointers, and we plug that back in. We use this equation. So x plus 8 equals 30. So we'd subtract 8, and we're going to get x is 22. So I made 22 2-pointers and 8 3-pointers. Okay, number 4 now is a rectangle problem. Rectangle is 7 inches longer than it is wide. If the perimeter is 72 inches, how long is the rectangle? So anytime we're dealing with a rectangle, we're going to have length and width. And you can figure out what the L and W stand for there. So perimeter equation, remember that's the one that never changes. It's always 2L plus 2W. Well, the only thing that changes is what it's equal to, which in this case is 72. Then our other equation, it's 7 inches longer than it is wide. Whatever Whichever side's bigger, you put by itself. So L equals 7 inches longer than the width. We could write width plus 7 or 7 plus width. Okay, this problem sets up well for substitution. You got one equation that the variable is solved for. So we can substitute W plus 7 for this L. So 2 times W plus 7 in parentheses plus 2W equals 72. So that gives us 2W plus 14. Bring down everything else. Combine your like terms. 2W plus 2W gives us 4W. Then we would subtract 14. And that gives us 4W equals 58. And then we would divide 58 by 4. And we get a width of 14.5 inches. Now, a decimal makes perfect sense when we're measuring the side of a rectangle. We could get 14.5 inches. So it's not necessarily wrong to have a decimal there. So if we plug that in, length is equal to 14.5 for the W plus 7. So that means length is equal to 21.5 inches. So there's our length and our width for number 4. Okay, moving to the next page. One more before we get to the classwork. It's the coin one. So Mark has $4.95 in quarters and dimes. He has 3 times as many dimes as quarters, so we're going to write a system that can be used to find Q, quarters, and D, the number of dimes. So there's our variables, Q and D for quarters and dimes. First, the value equation, the value of the coins. Quarter is 25 cents, so 0.25 Q. Dime is 10 cents, so plus 0.10 D equals $4.95. Second equation, he has 3 times as many dimes as quarters, so he's got more dimes. So we put D equals and 3 times as many, so 3 times Q. Okay, just like that last one, sets up great for substitution. All these application problems are pretty much either going to be using substitution or elimination. So we're going to substitute 3Q for this D here. So 0.25Q plus 0.10 times 3Q equals 495. That gives us 0.25Q plus 0.30Q when you multiply. Combine your like terms. 0.25 plus 0.3 gives us 0.55Q equals 495. And when we divide 495 by 0.55, we get 9. So divide by 0.55, and you get quarters is equal to 9. So if we plug that back in, dimes is equal to 3Q, so 3 times 9. So the number of dimes has to be 27. So we got 27 dimes and 9 quarters. Okay, so use that to complete the rest of the classwork and then the homework that goes with this.